Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi, I'm Dr. Rahana. Will be discuss to you how to analyze clipper. Now let's we look at example for our clippers in the case of the parallel circuit, and we're going to sketch the VR for the network. And if you look here, we have this external voltage, which is like a battery, is connected to with this diode, and we need to consider this voltage during the analysis. And we have the input, the maximum is 8 volt and the minimum is negative volt. For the positive cycle, we need to identify either is a forward or reverse direction. So in our circuit here, we can see that our diode is the same direction with the current. So now we are in the forward condition. So this is the first step. And the second step here, we need to identify the transition voltage. So transition voltage is the voltage that the VI need in order to allow the current flow go through to this part. Okay, so this voltage transition is, look here, we have silicon 0.7 and we have 4 volt, and here so we have 0.7 plus 4 volt, so it's become 4.7 volt. So our voltage transition is equal to 4.7 volt. So now we're going to look the possible condition of the VR when our VI is less than 4.7 volt and when the VI is greater than 4.7 volt. It is because we're going to look at what condition that our diode will be on or off. Okay, so we're going to look for the positive cycle for the both condition where when the VI is less than 4.7 volt and when the VI is greater than 4.7 volt. So for the first condition, VI is less than 4.7 volt. At this moment, we know that it less than our voltage. VI is less than from our voltage transition. So our circuit will be off. Due to that, our diode is not have enough voltage in order to be turned on. So our circuit will be like this one. This we have the open circuit. So how about the current? So how about the V out? So if we look here, V out is equal, since it's a parallel, that our V out is equal to our VI here. So whatever the value of the VI from 0 to 4.7, the V out is equal to the VI. So when we plot the graph, we can get that here is our V out since we are in the positive cycle. So from the 0, let's say here 4.7 volt. So from 0 to 4.7, here from 0 or from 4.7 to 0. So our graph is like this since our VI is increasing from 0 to 4.7. So what happened here? Either it's go high or lower than. So we need to identify that this condition for the second condition. So during this VI is greater than 4.7, and we know here that our diode has enough voltage in order to pass for this branch, so it's able to go through and the current able to flow. So at this moment, we're going to get that our V out is equal, since this is a parallel, so V out is equal to 4.7 volt. And this value is always maintained for every time or for every moment of the increment of the VI. So our V out is remain 4.7. So when we draw a graph here, during our voltage is greater than 4.7 here, our V out is always 4.7 volt. Okay. Next, for the negative cycle, again we need to identify either it's reverse or forward. And remember that we need to change the polarity here. So when it's going to the negative cycle, positive and negative. So and at this moment, we can see that our circuit is in the reverse condition. And we know that during the reverse condition, our diode is always open circuit. Even though that our diode here is always open circuit, we still need to analyze the transition voltage. So we know that our transition voltage is a 4.7 volt, and during this negative cycle also we need to look for the two possibility, which is either our VI is less than 4.7 at the negative cycle, or either that's VI is greater than 4.7 volt. Alright, so let's look for the first condition. At the first condition, our VI is less than 4.7, and we know that our V out here is parallel. V out here is a parallel with the VI. So when we do, so we can get that V out is equal to VI, or if you're using a KVL, you also can get from the outer loop here. And the voltage across this resistor is equal to the VI. So also we can get KVL is equal to VI. We can get positive VI plus V out is equal to 0. So VI is equal to negative V out, or we also can get the V out is equal to negative VI. So this negative actually is at of a negative cycle value. Okay, so at this moment when we draw a graph, we can look at our circuit from the negative cycle here. So we can get from 0 to, we have here 4.7 volt. Okay, so from, okay, we will follow whatever the value of the VI, this V out will follow. So we follow until 4.7 from here. So again, what happened at here? So we need to consider another condition, which is VI is greater than 4.7 volt. So during this also, again, we can do the KVL, and we're going to get a similar, which we get that V out is equal to negative VI. And at this moment, we can say that for the maximum of the VI, which is which is 8 volt, so V out is equal to 8 volt. So here, after 4.7, we can expand our graph here. Let's say we have 8 volt. So actually after here, this will go through to this one, right? Okay, so finally we can draw a proper graph in order to combine from the positive cycle and negative cycle. Now we're going to combine our circuit for this positive cycle and negative cycle. So how we going to combine? So now we have the graph for the positive and negative. So here we have V out. So let's we put here 4.7 volt, the transition, and here also we have 4.7 volt, and here we have 8 volt. So for the positive input from the 0 to the 4.7 is like this, and then we have here and here, and combine for the negative cycle we have from here to 8 volt around here. So we can get like this of our circuit. Okay, so now this is our final result for the V out. So the clip one is at the positive part where our signal is clipped here. Alright, that's all. Bye.